What's up? I was my Wi-Fi cut out last night, so that sucks. But on the flip note, I was having issues with this module error not found. It was up here in my library and I just cleared this out. Yeah, you can see it wasn't pulling from calculator, even though I had calculator right here in the same directory. I need to read up more on this. I don't know why it's doing that, but in turn, I went ahead and took this out and I tried it in just the main, I guess, file itself. I named it calci. And I went down here and did test calci and it is working. But if we were to run like this, I think it would, boom. So there's kind of like the air check shit he was talking about last night. So let's let's do this. I gotta go here soon in like 15 minutes, but I just wanted to rip some of this out and give a small update on that little issue I was having before the Wi-Fi went. So, all right.
I'm going to cross my fingers here, but for naught, I'm going to see immediately that 3 squared was not 9. Now, what is it? Okay, name underscore underscore equals equals, quote unquote, underscore underscore main underscore underscore, then go ahead and call main. So a lot of this is just boilerplate. Like we've seen this before, defining a main function and calling a function to kick off some process. Now adding the conditional at the bottom of the file to make sure I'm only conditionally calling main just in case I import anything from this file elsewhere. So let's see. Let's go ahead and test my code now. Let me go ahead and run test calculator with Python and hit enter, and nothing outputs. Nothing outputs. But I think it's OK. I think no output is good because look at my test square function. I'm not printing anything if all seems well. So let's demonstrate as much by going back to my calculator and let me break it. Let me introduce a bug. Maybe I didn't even get it right the first time. Maybe my code originally looked like this. I wasn't thinking. I forgot my squares. And so I thought that the square of a number is n plus n instead of n times n. So a reasonable mistake to make, perhaps arithmetically. Let me now go back to my test calculator, which I'm not going to change, but I am going to rerun it. Python of testcalculator.py. I'm going to cross my fingers here, but for naught, I'm going to see immediately that 3 squared was not 9. Now, what is it? Well, let's see. When your tests fail, how can we put our finger on what's wrong? Well, it's a little interesting that I completely broke my square function, and yet only one of these tests is failing. It looks like this test, lines 9 and 10, is fine because I'm not seeing that output. But of course, these 2 lines, this test is failing because 3 squared is not 9 when I'm using plus. So just to be clear here, why is my function only partially broken? Just to be clear, why am I
2 plus
seeing
2
only
is
1
4.
error instead of 2, even though the square function is now mathematically broken?
Because 2 plus 2 is 4. No.
Yeah, I mean, it's as simple as that. I just got lucky that 2 plus 2 is the same thing as 2
That's why
times
we
2.
put in
So this is
2
one of those
checks.
corner cases. And this is why it's good to be in the habit of not just testing one thing, but test several and make sure you're covering your bases, so to speak. So I got lucky here, and that explains why I'm seeing only 1 error, even though the function itself is flawed. But let me propose that there's another way we could do this, because honestly, if I extrapolate from this simple example, running not just 2 tests, but 3 or 4 or 10 or 20 tests, you can imagine that, my God, the code is going to get so much more complicated than the function itself. I mean, already, look, in calculator.py, the function in question is 2 lines long. And yet in test calculator, the code in question is 5 lines long. Like, I've written more code to test my code than I actually wrote original code. So the fewer lines of code we can write when testing code, I think the more likely you and I are to do it, because it's going to be literally a little less work, and just fewer opportunities for mistakes. So what's another approach I can take here? Well, it turns out in Python, there is another keyword that we haven't yet used, which is this here, assert.
Ooh.
Assert is a keyword in Python and some other languages as well that allow you to do exactly that as in English, to assert that something is true, to sort of boldly claim that something is true. And if it is, nothing's going to happen. No errors are going to appear on the screen. But if you assert something in Python and it is not true, that is, the thing you're asserting, a Boolean expression, is false, you're actually going to see some kind of error on the screen. So let's go ahead and try this new keyword as follows. Let me go back to my code here. And just to make it a little simpler, let me propose that I use this new keyword as follows. Let me simply assert that the square of 2 should equal 4. So I've changed my logic. Instead of checking for not equals, I'm now asserting very loudly that it should equal 4. And then on one additional line, let me do the other test. Assert that the square of 3 equals 9. And that's it. No if, no indented print. I'm just going to assert more simply these two things that I want to be true. Well, let me go ahead now with calculator.py still broken. I'm still using plus accidentally instead of multiplication. Let me go ahead now and run Python of testcalculator.py. Crossing my fingers as always, but it's not going to go well this time. A whole lot of errors seem to appear on the screen. And if I scroll up here for this traceback, we'll see that the thing that failed was this line here. Assert square of 3 equals 9. Now, unfortunately, when you're using the assert keyword, it's not terribly user-friendly. It shows you the files and the line numbers involved, but it does show you the specific line of code that failed, the assertion that failed, so to speak. It's now kind of up to you and me to infer from this, well, wait a minute, why is the square of 3 not equal to 9? So it's not super user-friendly, but honestly, it was like half as much code for me to write. It's just 2 lines instead of those previous 4. But notice this little remnant down here. This was an assertion error. And we have seen errors before. We've seen errors before when we've made other mistakes in our code. And in the past, what was our solution for catching those errors? How do we catch errors that seem to resemble this, even though we've not seen this one before?
Try and accept.
Yeah, in Python, we can use the try and except keywords to try to do something optimistically, except if something goes wrong, do something else instead. So this is a step forward in that I can at least catch this error, but it's going to be perhaps a step backward in that I'm going to end up writing, I'll admit in advance, a little more code instead. So let me go ahead and try this. Let me go back into my code here, and instead of just asserting blindly, let me go ahead, as Tolu proposed, and try to do this first assertion, except if there is an assertion error, like we saw a moment ago, then go ahead and print out something more user-friendly that explains what actually failed. 2 squared was not 4. And let me go ahead similarly and try to assert that the square of 3 equals 9, except if there's an assertion error there, in which case I'm going to print out, more user-friendly, 3 squared was not 9. So I've taken a step forward, but also a step back, because now I have more code, but I have at least introduced assertions and exceptions in a manner consistent with how we've seen in the past. When something goes wrong, you actually see an exception raised. Well, let me go ahead and run this version of the program now instead. Python of testcalculator.py, crossing my fingers. All right, it still failed because I'm seeing output, but we're back to at least user-friendly output. So that's at least progress in some way here. But it's, again, more code than might have been ideal. And in fact, if we continue this further, what if we actually want to add additional test cases here as well? Well, it seems like we might end up writing way more code than would be ideal. For instance, I'm testing 2 and 3 now. I should probably test some negative numbers as well. So why don't I go ahead and add in, for instance, let me go ahead and copy and paste this. Let me try to assert that the square of -2 equals 4, which should be the case mathematically. And if not, let me go ahead and change this to say -2 squared was not 4. And you know what? Let me go ahead and copy paste this again, test another negative number just for good measure. Let's test the square of -3, which should equal 9. But if it doesn't, let's go ahead and say that -3 squared was not 9. And just to think aloud here, what might be another good value to test? I've tried 2, I've tried 3, I've tried -2, I've tried -3. I can't try in infinite numbers, but there's at least something that's a little different in between those values. Let's try 0. 0 is an interesting case too, just in case something might be wrong. And why 0? I'm just going with instincts here, right? Odds are positive numbers are generally going to behave the same. Negative numbers might generally behave the same. 0 might be a little anomalous. There's no science to it necessarily, but rather considering for yourself based on your own experience, like what are the potential corner cases based on the function you're trying to test. I'm trying to test something mathematical, so I want to test representative values. So let me go ahead and paste in one more try except block. Let's assert that the square of 0 should equal 0. And if not, I'll say something explanatory like 0 squared was not 0. Now if I go ahead and run this, Python of testcalculator.py, and hit enter, now I see multiple errors. And this is interesting. It's a bit of a clue because notice that some, but not all of these assertions are failing. The one for 2 squared is apparently OK, as we noted earlier. Recall that 2 squared happens to be 2 plus 2, so that bug doesn't really throw off our test. But it's a good thing we tested for 3. It's a good thing we tested for -2 and -3, because all of those tests caught this error. The 0 test did not notice, because 0 squared is, of course, 0, but 0 plus 0 is 0. So we're getting lucky or unlucky there, depending on how you view the glass as half full or half empty here. We, at least by way of having multiple tests, caught this mistake somehow. So it would be nice, though, if we weren't writing so much darn code here, right? Because notice what I've done. I have try, except, try, except. I have all of these assertions. I have a main function. I have this if conditional at the bottom of my file. I mean, honestly, who's going to want to write 31 lines of code now just to test a 2-line function, right? No one's going to write test code like this if we're all writing so much more code to do the actual testing. So people have solved this problem. If you are in the habit of testing your code a lot or wanting to, if I'm in the habit of wanting to test my code a lot, if everyone else in the real world is in this habit of wanting to test their code, why don't we create tools that make it a little easier to do so? And in fact, there is a mechanism for doing this whereby we can use a tool that's popularly called PyTest. So PyTest is a third-party program that you can download and install that will automate the testing of your code so long as you write the tests. But what's nice about this library and others like it is that it adopts some conventions so that you don't have to write as many lines of code yourself manually. They do some of that automatically for you. Now, this is a third-party library. There's other libraries for unit tests, so to speak, that is testing units of your code. Some of them come with Python itself. We're proposing that we look at PyTest today because it's actually a little simpler than the unit testing frameworks that come with Python itself. And what do we mean by unit testing? Unit testing is just a formal way of describing testing individual units of your program. What are those individual units? They're typically functions. So unit tests are typically tests for functions that you have written. Now, what does this mean in practice here? Well, let me go back to my VS Code here, and let me propose that we simplify my test calculator significantly. I'm going to go ahead and delete all of these tests, which were accumulating to like 31 lines of code. And let's see if we can distill the tests to their essence using PyTest.
Thanks, David.
From my same calculator program, let me still import square. So I do still need that line of code so that I can test that specific function. Now I'm going to go ahead and define a function just like I did before as follows. I'm going to define a function called test square, again by convention, test underscore, and the name of the function you want to test, though it doesn't have to be that way. And now I'm going to go ahead and make a few assertions. I'm going to assert that the square of 2 should equal 4. I'm going to assert that the square of 3 should equal 9. I'm going to assert that the square of -2 should equal 4. And I'm going to insert that the square of -3 should equal 9. And lastly, for now, I'm going to assert that the square of 0 should equal 0. So I'm still using the assert keyword, as I introduced earlier. And even though it was a little tedious to type those, I mean, it's only 8 lines of code now, and they're so easy to type. It's not try and except and all of this. Wouldn't it be nice if something else, someone else, handled the try, the accept, the
4949
printing, all of the standardization of actually running these tests? And that's where, indeed, PyTest comes into play. Per the documentation for PyTest, which can itself be installed with pip install PyTest, which we've used to install other libraries in the past, you can look at the documentation here for all of its formal usage. But fortunately, PyTest is pretty user-friendly as testing frameworks go, and it actually allows us to dive right in by just running PyTest on the code that we've written. So if I go back to VS Code here and look at my testcalculator.py, which notice has no main function anymore, it has no conditional, it has no tries, it has no accepts, it has no prints, it just has my few assertions, PyTest and other libraries like it are going to automate the process of running these tests for me and informing me on the screen whether or not any of those tests failed. So let me go ahead and do this. I'm going to go ahead and increase the size of my terminal window for a moment just so we can see more on the screen. And I'm going to run not Python, as I've been doing. I'm going to run PyTest, which again is this third-party tool for running tests in your code. I'm going to run PyTest of test underscore calculator. So that same file, I'm going to cross my fingers as always and hit enter. And we'll see that, something has failed. Now, admittedly, even though I do think you'll find that PyTest is relatively simple to use,
Forgot to save it.
Its output, at least at first glance, is not necessarily super user-friendly. So what are we seeing here? Well, notice at the very top of my window is the command that I ran after my prompt. Right below that is a single F in red, which means fail. So not very encouraging. I tried really hard here, but fail is my grade on this program. But let's see exactly what happened. Well, if I look at this excerpt here, under failures, you'll see that test square is the function that failed. All right, that makes sense because that's the only one I wrote. And you'll see here somewhat arcane output describing what the error was. So what you're seeing here is the first line of output, equals 4, which is fine. There's no red error message below that, so that one's OK. But this line of code here, assert that square of 3 equals 9, PyTest did not like that assertion because it didn't end up being true. In fact, per the red E at the start of this line, you'll see that I'm effectively trying to assert that 6 equals 9. Now, where did the 6 come from? OK, wait a minute. If my test involves this, notice that where 6 equals square of 3, this is saying that because I've called square, passing in a value of 3, it turns out its return value is 6. And of course, mathematically, 6 does not equal 9. So that's why this is failing. Now, PyTest is not as user-friendly as telling you exactly why the bug is there or how to fix it. This is really just a clue to you what must be wrong. What you're seeing here is a clue that the first test passed because there's no red error below that line of code, but this test failed. Somehow or other, your square function is returning 6 when passed in 3 instead of 9. So at this point, you sort of put your detective hat on, you go back to your actual code, and you think about in calculator.py, how in the world is line 7 of my square function returning 6 instead of 9? And at this point, odds are the light bulb would go off above your head proverbially, and you would see, oh, I'm using addition instead of multiplication. But what PyTest has done for us is automate the process of at least pointing out that error for us. And if I now go in and fix this, let me go ahead and the light bulb has gone off. I changed the plus to a multiply.
Step ahead of
Now
you,
I'm going to go ahead, and after clearing my screen, I'm going to run not Python, but PyTest of testcalculator.py, crossing my fingers again. And now it's green, and I see just a dot, which indicates that my one and only test passed. I'm good. 100% success with my test now after fixing that bug. All right, let me pause here and see if there's any questions.
So my question is, what?
We're done with it. We don't care about that question. We'll double back. I got a dinner coming up here soon, so I'm out. I might come back and study a little bit more because I just want to get these lectures over with, but thanks.